Hello, this is Patrick, and today I'm going to be going over Activity 1, Unpacking a Standard. I'm using the Screencast-O-Matic here, and let me just pull up the presentation. So in this case, since I'm teaching science at a school in Zhuhai, China, I'm going to be covering NGSS standard MS-ESS1. It's a middle school, MS middle school Earth Science S1, Earth's Place in the Universe. And this is going to be going into some detail about very particular science phenomena. Let's unpack the first question here, which is what is the standard, its source, and why did I choose it? In this case, the standard, as I said, is MS-ESS1, commonly known as Earth's Place in the Universe. And this is from the Next Generation Science Standards, which were released about 5 years ago now and have been slowly generating their way into the classrooms, and teachers have been getting PD on this for about the last 3.5 years. Why did I choose this standard? This is really, the standard's a really great way to start the school year because it gets students thinking about things that they're kind of already conscious about, such as the moon and the seasons. And it also gets them thinking abstractly about scientific ideas that they might not be able to just handle or touch. They have to think sort of big picture. Even though they can see the moon cycles, they can't see what's causing it, so they have to think abstractly about it. To compare this to another standard that I was thinking about, which is MS, Middle School, Earth Science S2, Earth Systems, I think this is a better one to do because I'm doing it earlier, and also there's a bit more abstract chemistry with Earth Systems standards as they go into some things like the nitrogen cycle. So that's the reason why I chose it, its source, and what the standard is itself. Second here is the grade level and subject addressed by the standard. This is middle school Earth Science, and the subject is Earth's place in the universe, as exemplified by its relationships to its closest celestial bodies. So that includes the sun, the moon, and sometimes the other planets and how they interact. The big ideas in the standard are the lunar phases. We go through the lunar phases with the students. We talk about the eclipses of the sun and moon, what causes an eclipse, why do they happen, and then third is the seasons. And students often have really specific ideas about all of these. Oftentimes they have alternate conceptions to what the actual scientific reality is. Skills that students must use here, skills that students must use to meet the standard, number 4 here. They have to develop models, for example, of the Earth, Sun, Moon system. So developing models is a big part of this, and not just a model isn't just like building a representation of the moon, for example. It's showing the phenomena of what causes the phases of the moon. So you have to include sort of the dynamic idea of the scientific concepts and phenomena under study. The second thing that students have to do, the second types of skills they have to go through is and learn is analyzing and how to analyze and interpret data. For example, you might look at how often the moon is full versus half versus waxing and waning. What's some statistical numbers on that? How often is it happening? That sort of thing. Drawings to show the representations, maybe photographs from telescopes that one could get online. So how to use that data, interpret it to make some explanations, which is the next phase here of constructing a scientific explanation, or the next skill. How do you construct a scientific explanation based in evidence, and how do you logically make a series of statements that are supported by evidence that can be convincing. So those are the three skills students are really needing to use to meet the standard. I used a number of different activities to help the students meet the standards. One is an eclipse lesson that I got from the University of Louisiana. It's used by the State Board of Education there. And this includes hands-on activity where they construct a keyhole eclipse view box, something you may have seen if you saw the eclipse a few years ago here. And they can build it and then simulate what it might look like when there's an eclipse going and why they see what they do through the eclipse keyhole box. And so that's one form of activity that really helps them think about the conceptual idea and ground it in reality. And then the lunar phases lesson, which is more of a drawing lesson where they're drawing illustrations of moon phases and then using data to back up the drawings that they're showing. So those are two activities, and if you click on the link, here's the eclipse lesson. If I clicked on this link, I don't know if it's going to come up for me. There it is. You can see the middle school eclipse lesson, and here's the boxes that I just talked about. You can use like a Coca-Cola box or what have you. Go back to our slideshow. And then the lunar phases lesson, it's not letting me click on it here, so I'll have to double check that link. And so finally, how do we think about assessing students' mastery of the Earth's place in the universe? Assessment's a big part of this. One is they get formally assessed on their models that they build. So like for instance, in the phases of the moon, they're drawing these illustrations, and they have to explain it with data and present it in a form that can be graded. And it's based on a rubric of completed, logical information, somewhat completed, some of the information is missing, or incomplete. The information is not showing that they understand the phenomena of phases of the moon. Oops, come on back. And then finally, the last phase is the, and I'll get back to there. Sorry, this is going all over the place for some reason today. And the last piece there for assessment is just a straight up test. Students will be given a formal test assessing their understanding of key terms and ideas such as elliptical orbit. That's it for this presentation. Hopefully it was helpful, and I'm under time here, so that's a good thing. Thank you.